Hi, everybody. Good morning, good afternoon. I'm very excited to be here with you, invited by IMAGINiT to talk about the future of technology. But before we get started, let me share with you a little bit about my background. I've been living in Boston for about 18 years, but I'm originally from France, and you can see a picture from my village back there. I'm a father of 4 teenage daughters, so it's been a lot of fun during COVID to spend time with them. I can tell you about that. And my background is in computer science, civil engineering, and structural engineering. I've been at Autodesk for about 18 years, and I had several roles around product management, strategy, and marketing. And today, I'm running the global strategy for the AEC markets. So I'm going to turn off my video so you can enjoy the full screen of my presentation. For me, the future of technology is synonymous with digital transformation. I'm sure you've heard about that term, digital transformation. And actually, different people use different terms. Some say digital transformation, others say digitalization, and I'm sure you also heard digitization. Actually, digital transformation and digitalization mean the same thing, and digitization is very different. And here you can see the definition of digital transformation versus digitization. Digitization is the conversion of analog to digital. So it's an existing process. Instead of doing it in an analog way, you do it digitally. And digital transformation is the use of digital technologies and digitized data to impact how the work is being done. It's a true transformation on how you work, your customers work, and then how you create new revenue streams. Actually, in AEC, we already experienced 3 digital transformations. The first one was moving from hand drafting to CAD. It was a major change in the way you work. The second one was around BIM and 3D modeling. And it was an even bigger change from 2D drafting to 3D modeling. And the last one was actually quite recent. It's when we started to collaborate with the cloud and using these technologies to access data from anywhere on any device. And you just heard about BIM Collaborate Pro and BIM Collaborate earlier today. So the question is, what's the next transformation? So the first one was powered by CAD, the second one by BIM, the third one by the cloud. And we know that machine learning will be igniting, the next digital transformation. The question is, when is it going to happen? To better understand when the next transformation will happen, we need to look at the process of digital transformations. And here on this chart, you can see market adoption of different types of technologies, starting with innovators, early adopters, then they cross the chasm, and the large majority of users would use this technology. And finally, people that are more on the late majority side. But each technology actually follow the same curve. And you can see the blue chart that represents that curve. First, the technology is introduced, then there is a catalyst, and then it accelerates until it reaches a plateau of productivity. And this plateau, we've experienced it, a few times, as I talked about. And the catalysts were different. For CAD, the catalyst for the acceleration was personal computers. For BIM, the catalyst was really 2 things. Downturn, because what happened in the years 2008, 2009, 25% of the AEC industry was out of work. So during that time, a lot of the professionals learned BIM and started to use it after the recession when things were better. But also with mandates, and public and private owners, so governments and private owners, started to mandate the use of BIM. They said, I want a BIM project. And the goal at the time was really to be on time and on budget. For the third digital transformation, which is the cloud, no surprise here. The cloud was accelerated by COVID. COVID was the catalyst for this complete transformation. And today I can tell you from what I see with the Autodesk products, there's a very large majority of the industry that transition to the cloud. The other interesting thing is if you look at the duration of these transformations, the first one took 20 years, then the second one 14 years, then 6 years, because we can say that we already transitioned. So there's also an acceleration of when these transformations happen. The other nice thing about the transformations in AEC, it's they build on top of each other. CAD is still a big part of the BIM process, and you cannot do cloud collaboration without BIM. And the next transformation that will be about getting better insights and automation will need data, and the data will be created with BIM, with CAD, and it's going to be shared with the cloud. So it's interesting that you see that the value builds as we go through multiple transformations in the AEC industry. So the question is, what will be the next disruption? When will it start? And who's going to be the driver or the catalyst of this transformation in AEC? It's a lot of questions, and I don't have a crystal ball, but I can share with you some of what we think at Autodesk about this next transformation. So in order to understand what the next catalyst is, we need to look at the bigger trends. And in our industry, whether you design and build a building or a plant or a bridge or a road, there are two big categories of drivers. The first one on top is the demand. And globally on the planet, the demand will just be enormous in the next several decades. And it's driven by urbanization. Even though COVID slowed down, people moving to cities, but the longer terms, remain solid. And a lot of the population will move to cities and will reach close to 70% of the population living in cities by 2050. The population is also growing from 3.5 billion to 10 billion in 2050. And then there's post-COVID. We need to reconfigure the entire built environment. We need to make it safer. We need to be proactive in case there is another pandemic in the future. And then the number of natural disasters keep increasing. So there are more flooding, more earthquakes, more fire. So all of that is going to create demand to build or to reconfigure the existing built environment. And at the bottom, it's all the things that we need to improve. Productivity, there's a ton of waste in the industry. Sustainability, we need to do better in terms of carbon, in terms of water. And then the workforce is retiring, so we need to be more productive. And the resources are more expensive, and there's scarcity of some of the natural resources like water, like sand, etc. So when you look at all of these forces, they will be a catalyst of change. And to me, what's going to change and what will be the catalyst of the next transformation, it's going to be driven by owners. Whether they are public owners, governments, or they are private owners, they just will want better outcomes because the demand will be big and we need to do better. We need to be more productive, design and build assets that perform in a much better way. And we started to see it. We started to see governments around the world mandating the use of BIM. We started to see in the US, for instance, the GSA is already requiring to use BIM for facility management. The Internet of Things is exploding with billions and billions of data. And owners are now part of some of the top trends in terms of smart spaces and smart buildings. And all of that is just going to accelerate the next digital transformation. So if you look at the AEC Lifecycle, I'm sure many of you have seen a diagram like this. And it was done mainly to tell the story around architecture, engineering, and construction. But if you are an owner, you see the life cycle in a much different way. Because the total cost of ownership for an owner is really in the operation phase. It's post-construction. 70% of the cost of ownership happens post-construction. So the way owners think about the life cycle is around, of course, the design, the construction, which is the capital project phase, but also the operations. And what they will want in the future, it's really to monitor what's happening during the operation phase and use all of these insights for planning purposes to either reconfigure existing assets or build new assets. They want to learn from the past or the existing assets in order to better improve or design new facilities, new assets. So that wide part of the life cycle becomes critical for owners, and that part will drive that transformation. And at Autodesk, in the past, we've been building software, tools, services, really to support the A, the E, and the C's for the design and construction process, but we didn't yet spend too much time building solutions for the wide part of that life cycle. So what do owners want? So they want three things to achieve better outcomes. So what we've been hearing more and more, it's they want a digital twin. And they want this digital asset delivered at the end of construction so they can leverage the asset post-construction. They want better insights in terms of how their assets work, in terms of their occupants, their energy, but also during the design and construction phase, they want a better control about how the project is going. Is it on track? Is it on budget? So they want to track the capital project phase. They want to get also insights in terms of the operations, and they want to use all of these insights for capital planning. And finally, they want to automate. And here, more and more, when I talk to owners, private and public, from all over the world, they tell me that they believe we can automate a lot of things in terms of design, with generative design, in terms of construction, with using DFMA, design for manufacturing and assembly, but also automate some of the reporting during the operation phase. And we'll talk about each and every one of these needs from the owners. So first, let's talk about digital twin. Today, at the end of a project, the owners receive a ton of paper. But that's not what they want. Just like general contractors will deliver a physical asset, what they need is a digital asset, exactly the same one. And they don't get it today because the models that are created during construction, for the most part, are models for the purpose of design or construction. It's for quantities, it's for performance, it's for a lot of different reasons, but it's not for what the owner wants to operate the facility. So first, let's talk about digital twin. So first, let's talk about digital twin. Today, at the end of construction, during the handover, owners receive a large quantity of paper. But what they really need is different. Just like the GCs and subcontractors will deliver a physical asset, a building, a bridge, a road, whatever the case might be, what owners want more and more is a digital asset. They want a digital asset that they can leverage post-construction. And that asset, that digital twin, is not a model that was created for fabrication or a model that was created for energy or structural analysis. It's not a model that was created for clash detection or quantity takeoff. They really want a model that they can use post-construction. So really, what owners want more and more is a digital handover. And the digital handover can really help achieve better outcome by providing a data-centric platform for collaboration between the owner, the architect, and the contractor. And more importantly, at handover, it provides easy access to detailed facility information through a digital twin that can rapidly accelerate the operational readiness of the facility. Just to be crystal clear, owners want two things with this digital twin. Number one, they want to be able to collaborate seamlessly with architects, engineers, and contractors during the design and construction phase. And second, once the digital handover was done, they want to be able to leverage all of this information and connect it to all of the systems they have in their building. So what is a digital twin? A digital twin is a digital replica of a built asset that is dynamic digital reflection of its physical self. Digital twins possess the operational and behavioral awareness necessary to simulate, predict, and inform decisions based on real-world conditions. And I'm going to show you some examples of that. At Autodesk University, we announced Autodesk Tandem. It's a new solution in beta right now. Autodesk Tandem is a digital hub that can integrate with new and existing systems to connect the digital model to the operational and performance data of its physical counterpart. Autodesk Tandem is a powerful tool that integrates the rich information created during design and construction and transforms it into a holistic view of the project. Here you are seeing a science and biomedical research facility on a university campus. Over the course of design and construction, a project like this one generates millions of data points. From defining the use of the space for things like flow, classroom organization, window configuration, to the systems that support the space like structural and MEP, and all the way down to a specific element like an air handling unit. A unit like this one may have thousands of pieces of information associated with it, and that's just this single unit. Imagine all the elements in this facility and all the data associated with them. Tandem captures this vast amount of valuable digital information and places it at your fingertips in an organized and structured way that tells you a story about the data. Tandem provides context. When Tandem launches, it's going to support a broad set of information captured during design and construction, including all Revit models, IFC data, and construction as-built. Post-handover, Autodesk Tandem becomes a digital hub integrating with new and existing systems to connect the digital twin to the operational and performance data of its physical counterpart. One thing is clear, there is no single source of truth. However, by connecting to operational systems, we can create an ecosystem that provides a cohesive digital twin solution. Okay, point number one was digital twin. Let's move on into insights, and let's look at insights in particular during the operations phase. So the operation phase is really so point one was around digital twins. Now let's talk about insights. And let's talk about insights specifically during the operation phase. And it's really about monitoring all of the data during operations. So here what you can see is an image of visualizing sensor data on a BIM model. And what's important in terms of monitoring sensor data, it's really to represent the data on a 3D model, because there are thousands of sensors inside the building. It's really understanding live data, but also data that happened in the past. So it's about having a time history database. And the third one, it's to look at all of the sensors in a common visualization standard, because you will get sensors from different providers. Each of these providers have different sets of visualization tools. And what I think is important is to normalize the visualization of any kinds of sensors in the same environment. Because if you want to look at sensors, you cannot look at 5 or 6 or 10 different systems. Here's an example of some of the sensor data that were implemented years ago on one of the NASA's buildings. And what you can see is the variation of temperature over time in this building. And you can see that some rooms, the temperature becomes red, so it means the rooms are hot. And then when it's blue, it means the rooms are cold. So an owner, an operator of this facility, can understand dynamically in real time the temperature in the facility and can do two things. So optimize in the short term for energy performance, but also use this information for the design of the next building. So it's one way of capturing insights from the asset. Another way to capture insights, it's also about the occupants of the building. And moving forward, it's important to track the behavior of people. And here you can see on this research project how we can create a digital twin of the occupants. But the reason we do these stick figures for the people is to keep privacy and get data that's anonymized for consumption. So once you start capturing data, you can really start visualizing this data in different ways. And what you can see here is how people consume the building over time. And in this animation, we see time. We also see difference of temperature, and we see the behavior of people based on temperature. So for instance, if you're an architect and you think that people should go in that part of the building, let's say it's a retail store, and you can see they go the other way around, then you can start understanding why is the behavior like that. I did not intend to have that behavior. But also you can capture the behavior of people and you can use it downstream for other facilities. And I'll show you an example of that. This last example is actually really exciting. It's Notre Dame, and Autodesk is one of the companies that's providing, BIM models and informations and solutions to support the reconstruction of Notre Dame. So, of course, being from France, I've been quite involved with the project and supporting the team working on it. And as you know, Notre Dame, the roof collapsed because of fire. So understanding, temperature in the future will be important. And the owner of Notre Dame is looking at putting sensors to really understand what's going on and to predict if there's another fire or another disaster. So it's been an interesting process, working with a team that's working on the design and construction of Notre Dame to see how they are embracing these new technologies. And for them, I can tell you, given the age of the cathedral, it's a pretty significant digital transformation, because the way it was built, the way it was operated was, pretty old in their process. So using the latest and greatest for that in the future will be fascinating to see. The last part I want to talk about is around automation. So let's dive in. So automation here could be introduced for operations and monitoring and building, but I'm going to focus on the part of the impact on design and planning. So for this example, I'm going to talk about this company Airbus, and they are building this facility for their new A350, and that part is really a place where they build the wings, right? So as you can imagine, this building is pretty large because wings are pretty large, and typically on a plane there are 2 wings, so it's not about 1, but they need to have 2 at the same time. So at Autodesk, our research team has been working with Airbus to try to optimize how people work on the wings. And you would be surprised, but there are a lot of people actually, and they need to walk because the wings are pretty long. So they need to walk, they need to go and get their tools. And there's a lot of walking involved. And sometimes it could be, it's miles and miles every day just to go and get tools and things like that. So it's something that Airbus wanted to improve. So for that, we worked with them, and we modeled how people are walking from one place to another one. And sometimes it's to get specific tools, specific materials, specific paint, and other kinds of things. And we did this modeling, and once it's modeled, then we can iterate, and we could use machine learning to simulate multiple types of options, really to optimize around the least walking possible. And through this process, we identified thousands and thousands and millions of options, actually, but we could pick with them some of them. So Airbus was really interested in the process of using generative design for the space layout, and they asked us to work on their new facility. So Airbus was interested to do a research project with us from a new facility, and you can see the lot, from this aerial view. The lot is a triangle, so it's never easy to design a building that would fit a triangle. And multiple options were possible. So either it would be a 9,000 square meters, using the shape of the triangle, or something that would be smaller, but that would be more traditional and rectangular. So we explored these 2 strategies and work with Airbus to identify, the specific operational goals for this research project. And the goals were around engine flow and logistics and flexibility, but you can group them in operational goals, social goals, environmental, and financial. And we didn't know which one we would optimize because, you can optimize for 1 or 2, but it's really hard to optimize for the 4 of them. So the same way, we use generative design to explore, many options. And on the spider webs on the side, you can see the impact of each of these solutions right here. And just like we explored, a large number of options for the wing project, here we explored also as many options. And now the question was about trade-offs. So you can see the generative design systems learning over time and how to achieve better scores, with each zigzag line representing a design option. And lines higher on the graph are scoring better. So it was really a good tool to explore, the trade-off to pick the right facility. And the key criteria that Airbus ended up choosing were on construction cost, for sure, but also engine, paint, and logistic flow. So it's a good example of using machine learning and generative design to really explore a large number of options before you go in more detailed design. So you can understand the impact, the financial impact, the environmental, performance impact of the facility. And you can see, the final design. So that was a great, great daylight, renewable materials, and net zero concrete as well. That project with Airbus is exciting, but it was a one-off. It was custom software. And what we did, we announced also at Autodesk University back in November, we announced the acquisition of this technology called SpaceMaker. And SpaceMaker is really generative design at scale. So everything you saw with Airbus, the goal is to scale it with a SpaceMaker. SpaceMaker is a data-driven approach, and it's going to accelerate the AEC digital transformation. And the strength of SpaceMaker is artificial intelligence and machine learning. It's really a big investment in our vision for the future of design. And you're going to see a lot more from us in the months to come. So some of the things that SpaceMaker does, it looks at all kinds of analysis. So what you saw with Airbus was around cost, it was around distance, it was around the flow of people. But in addition to that, we can add all kinds of criteria based on wind or noise or daylight or view of apartments. So it's really using the power of artificial intelligence and machine learning to generate millions of different options. Another really interesting thing, I mentioned that owners are worried about the waste in construction. And that's why DFMA, or Design for Manufacturing and Assembly, is a growing trend around the world. And you can see, for instance, in some places like the UK or Singapore, the government has started to mandate the use of modular construction. But when you think about it, in the design phase, if we start with architects and engineers, and if they design the buildings and the facilities, knowing that they will be assembled or they will use, prefabrication, in terms of a complete module that represents a room, then the chances of implementing it downstream in construction will be a lot higher. So that's why, generative design and the future of generative design, it's really understanding what kinds of components are at the disposal of architects and engineers during the design process. So if you know that you have this type of components, and it can be a single component, it could be an assembly of multiple components, or it could be a complete room, then the software will be able to show you the different options and trade-offs. And that's something that's really exciting. And we are actually researching with Factory OS, which is a company in San Francisco. And we are looking at using generative design to see how we can design, the best facilities using that. So that's also part of the automation side of what owners want. And now it's my last example. It's a really cool one. And it's very timely because of COVID. And in this case, it's using the entire power of artificial intelligence to try to make an effect on the reconfiguration of the existing space. So this project is also something that Autodesk Research has been doing during the pandemic. And really, it's a system called OXIM. It's at the heart, it's really a system that brings three things together. So first, it brings spaces, architectural space, in the form of a 3D model. It brings some of the human behavior. And remember the animation that I showed you where we see people, behaving in a building. So that's that kind of data that we can also bring into the system. And the last one, it's more mathematical models that explain how the virus is transmitted from one person to another one. And when you put all of this together, you can start simulating the rate of contamination and the risks inside the facility. So first, the first part, it's about the spaces. And here, the research is about, two different areas. One is our office in Toronto, and the second one is a restaurant in New York. So all of this data has been created with a BIM tool and can be leveraged in this simulation tool. And remember, when I talked about digital twin, what I said is, a digital twin enables you to simulate, to predict and to inform. So here we are looking at the simulation and predict side of it. So number one, the space. Number two, it's the behavior of people. So we looked at how people circulate in a facility, and here it's captured for different personas, the customers of a restaurant, the bar manager, etc., etc. And then we can see the different behavior. This behavior could have been captured digitally like we saw, or in this case, they are input manually. And the last one, it's really the physics of transmission. And we know that the virus can be transmitted in two different ways. So airborne particulates, so at the bottom, because the virus would stay in the air. And it's when people talk to each other or when they cough, etc. And then on top, it's really based on high touch surfaces. So it's when you touch a door handle, when you touch an object, a ramp, etc., a desk. So these are the physics of and the modeling of how the virus can contaminate. And now when you put everything together in this digital twin, you can simulate what's going to happen. So we have these three databases all together, and we can mesh the environment and associate different risks in each of these spaces. So when it's a closed room, you can see the risks are higher. When it's a toilet, it's the same thing. And then you can also start understanding based on behavior if people are contaminating each other. So, using that, you can start working with your customers. You can start looking at the best synergies to optimize the design based on the risk that the occupants will take by being there. So that's another example of using insight and automation to drive the right outcome for your customers. So this is my last slide. So we know that the next transformation is coming. We don't know if it's going to be this year, next year, in 2 years, or 3 years. But the things that we know, it's going to be based on getting more insights, more automation, and it's going to be powered by artificial intelligence and machine learning. We also believe that that transformation, the next level of transformation after CAD, after BIM, after cloud collaboration, will be driven by owners and AEC innovators. They will be the catalyst for the change in this industry. And that's it for me. I hope you enjoyed the presentation. You can reach me at nicolas.mangon@autodesk.com if you have any question. So thank you again and stay well.